Here's our second example. Let's graph f of x is equal to negative log base 1/12 of x plus 1. Again, first thing we would like to find is the parent. The parent is in the form y equals log base b of x. So for our example, we're going to change f of x to y equals log, and then our base in this case is the 1/12. So we have 1/12 and then x. Okay, so the first thing that we want to do is we would like to pick 2 points that we would like to graph, and in order to get those, we're going to rewrite this equation in exponential form. So to write this in exponential form, our base is the 1/12. So we have 1/12 to the y is equal to x. That's our exponential form. Now we're going to pick y's. Whoopsie. Didn't want to write an equals there. We're going to pick y's and get x's. And like I said, we usually pick x's and get y's, but since this is the inverse and it's easier to look at exponential form than to try to figure out the log form, that's why we're going to pick y's and get x's. Now, a nice and easy y is 0. This point is going to be on every single log graph. If we pick 0 for y, our x will be 1 because anything to the 0 power is 1. Then, since our base is fractional, which is the 1/12, that's the fraction in between 0 and 1, we're going to pick a y that is -1 instead of a +1. That way, if we take 1/12 to the -1, we can then flip that over, and then that becomes a 12, which is a nice integer to graph. So first, let's go and let's graph this parent. Okay, we would like to graph 1, 0, 1, 0, which is right here. And then we're going to graph 12. Our x is 12, so that's all the way out here somewhere. And then our y is -1. So we're over here. Now, if you recall from the graphs that we looked at in the introduction, our graph, if our base is fractional, our graph from left to right is going to decrease, and our asymptote is going to be along the y-axis. So we're going to go and decrease from left to right. So the black graph represents our parent. Now we have 2 transformations to do. So the first one I'm going to point out in red, which is this one right here. Notice that the +1 is with the x, so that's a horizontal transformation. That tells us to go 1 to the left. And then the next one I'm going to make blue, and that's right here. This negative is going to tell us to do a vertical reflection. Okay, so first let's do our horizontal transformation. I'm going to change back to red. Okay, so that says take whatever you have, move it one to the left. My asymptote is going to move one to the left. This point right here is moving one to the left, and then my point here that was at 12 is now moving one to the left. So again, I'm decreasing from left to right. Then we'll change to blue, and we'll do the vertical reflection. Vertical reflection says take whatever you have underneath the x-axis and you're going to put it above. Anything above goes below. So notice that we've got this red point right here. It's right on the x-axis. That's going to stay the same. So is our asymptote. If we reflect that vertically, it stays exactly the same. But now this point right here is going to have to move to the other side. So that moves, instead of being one down, now it's one up. And so now if you notice your two blue points here, if you connect them, you're now increasing from left to right. And the blue one is your final graph.